Greetings. My name is Erwin Chinwenjie, and my metric number is 221061394. So I'm here to demonstrate the fuzzy classifier for our project. So the title of our fuzzy classifier is a fuzzy decision-making applications, fuzzy logic-based fruit type classification. So as indicated by the title, uh, our project is to classify 5 types of fruit based on two different features, which is size and weight. So there are 5 fruits that we want to classify. The first, which are grapes, apple, banana, honeydew, and watermelon. So let's take a look at our coding. So first of all, we need to install the necessary library, and then we need to import required modules, and then we define the mean and standard deviation of each fruit. So in this case, as you can see from the coding here, this is the mean and standard deviation for weight only. So the weight means and the standard deviations shown in this coding is associated with its respective fruits. So for example, apple has a weight means of 2 and standard deviation of 0.6. So the unit for weight I use is kg. And then for honeydew, it has a weight means of 3 kg and standard deviation of 1.2. And then the rest is same for the, I mean, we also define a different value of means and standard deviation for grape, watermelon, and banana. Obviously, watermelon has the highest weight means, which is 5 kg, and grape has the lowest weight means, which is 1.5 kg. So how do we define the membership function of for each type of fruit? We actually create 5 different membership functions for each type of fruit. So this is how we create it. So as you can see from this figure, the y-axis actually represent the probability, which range from the value 0 to 1. And then the x-axis represent the value of mean, and as well as mean minus sigma, mu minus sigma. Sigma is standard deviations. So in this example, the mean value is 4 and the standard deviation is 0.4. So this is the value is calculated and shown at the x-axis. And then for the slope, this is a triangular membership functions. It has 2 slopes, which is the rising slope and the falling slope. So for the rising slope, we call it as a left slope. It has its own mathematical functions, as well as the same goes for the right slope. So the mathematical functions for the left slope is represented by the gradient of the line, y equals to mx plus c. So the gradient is m. So this is how we calculate the slope functions, which is y2 minus y1 minus y2 minus y1 over x2 minus x1. And then in this case, the slope function for the left slope is 1 over sigma, which is 1 over standard deviation. So as for the right slope, it's declining, which means it has a negative value. So the slope function is, for the right slope, is negative 1 over sigma. So let's get back to our code. So this is the function to create a triangular membership functions, as you can see. So the left, this is how I define the membership functions based on my explanation just now. And then let's try to run the code. So as you can see, my code actually displayed individual membership function of each type of fruit. This is the apple, honeydew, grape, watermelon, and banana. And then I also create a functions to merge all 5 membership functions for the weight together. So as you can see, each membership function has a blue line at the center, which represent the mean value mu. And then from this figure, we can see that each membership functions intersect with each other. So this is how we test our fuzzy classifier. So the user has to input the weight of the fruit in kg. So let's say I enter a value of 2.35. All right, so as you can see, the blue dots here is actually the value in the weight, the value of weight input by the user. So I create a function to show the intersections of the value with the membership functions. So as you can see, there are four intersections of this value with different types of membership functions, as indicated by the blue dots here. So how the fuzzy classifier classify the fruit is actually based on probability. So basically, the intersection point with highest probability is the winner. So in this case, Apple has the probability of 0.41, and then Honeydew has a probability of 0.46, and then Grape has a least probability value, which is 0.06, around 0.06, and then watermelon has 0%, and banana has the probability of 0.83, which is 83%. So based on the fuzzy logic, the weight 2.35 kg is most likely banana with the membership with a membership function value of 0.83. So the fruit with the weight of 2.35 kg will be classified as banana. And then I also create the same coding for the size features. So as you can see here, this is the size features. So I have to define all the value of size, the mean of size, as well as the standard deviations using with different values. So obviously, grape has the smaller size, and watermelon has has a larger size value. Next, let's take a look at the coding for another feature, the size feature. All right, so this also I display all the individual membership function for the size feature for each type of fruit, and then I combine it together. So it looks like this. So in this case, only two of the membership functions will intersect with each other. The rest are independent membership functions. So let's try and see the value of 3.9. All right. So the same goes for this membership functions. For this fuzzy classifier. So the blue dots is the value entered by the user. So in this case, it only has two intersection point, which is so the point with highest probability will be the winner. So let's take a look. So in this case, okay, banana has the probability of 0.67, while apple has a value of probability of 0.25. So obviously, banana is the winner. So this value, the size 3.9 will most likely be is banana with a membership function of 0.67. And then I create an extra code, which the also fuzzy classifier, which classify the types of fruit based on two types of features, which is the combination of size and weight. So let's take a look at let's run the coding. right. So let's input the value for the size first. This time I'll choose like 2.6. And then as for the weight, I'll choose 3.1 kg. So, okay, for this for this fuzzy classifier, the dots will be represented by red dots, the value input by the user. So, okay, so based on these two features, the value of size and weight, it will classify, okay, the fruit with the size of 2.6 cm and weight 3.1 kg is most likely apple with a membership function of 0.5, which is 50%. So for the size, so this one actually requires a lot of computational functions. So this is just an extra code that I create to see the variations in fuzzy classifier. So that's all from me. Thank you.